In this lesson, we're going to use simulations to mimic reality by using random numbers to represent the outcomes of real events and answer different questions. So let's look at the vocabulary related to simulations. So each time we obtain a simulated answer to whatever our question is, it's called a trial. We're going to be doing multiple trials to come up with our answer. We're going to actually run a simulation to understand the vocabulary and the important parts. So our first scenario says, suppose a cereal manufacturer puts pictures of athletes in their boxes to boost sales. The manufacturer announces that 20% of the boxes contain basketball star LeBron James, 30% contain football quarterback Tom Brady, and 50% contain tennis champion Serena Williams. You want all three pictures. How many boxes of cereal do you expect to have to open to get the complete set? So I don't know about you, but that happened when I was a kid. I was trying to collect all the boxes. So would I expect to be able to open the first three? If you were really lucky, but if you were like me, you had to open lots of boxes until you got what you wanted. So describe how you will use a random number table to simulate one component. So here's a reminder that this is what a random digit table looks like. Remember, computers and calculators are pseudo-random, so we're going to try using a random digit table. So imagine somebody's rolled a 10-sided die to create this over and over, probably the most boring job in the world, but this would truly be random. The question we're trying to answer is, of course, how many boxes of cereal do you have to open to get our complete set? So we're going to begin by describing how to simulate one component. And that's like our building block of our simulation, which in our scenario is opening a box. So one of the things I'm pointing out right now is that the percentages we're given, 20%, 50%, and 30%, are all multiples of 10. That's important because that tells me I can use single digit numbers because there are 10 digits from 0 to 9. So I need 20% of these numbers to represent LeBron James. So I can let 0 and 1 represent opening a box with LeBron in it. Since I need 30% of the numbers to be Tom Brady, right? So that would be 3 out of 10. So I'll let 2, 3, and 4 be Tom Brady. And then the remaining 5 would be 50%. So 5 through 9 would represent Serena Williams. Okay, so I have also here on the side said LeBron will be L, Tom Brady T, and Serena S. I just am anticipating having to write some things out, and that will help me with my shorthand. How will you combine the components to simulate a trial? So I'm going to simulate a trial, meaning until I will select random digits until I have a card of each athlete. And then the response variable, like what is it I'm measuring or what is it I'm trying to figure out at the end, I'm going to count the number of boxes I must open until I've obtained all three pictures. So let's actually run the trial. On here it says let's run it 10 times. I'm going to show you just 2 using the random digit table. So trial number 1 here, as I move across the random digit, I have a 1, a 1, a 1. Okay, so the first one, of course, represents LeBron. The next one, LeBron. Third one, LeBron. Then I have a 6, which we said was Serena, and a 4 is Tom Brady. So now that I have all 3 athletes, I'm going to count how many boxes I opened. And I count 5. So my second trial will begin where I left off. Okay, so I'm going to begin at this 3, which represents Tom Brady. Then I had a 6 is Serena Williams, another 3, Tom Brady, followed by a 1, which is LeBron. So I have all 3 athletes, even though I have 2 of Tom, and I had to open 4 boxes to get that. Okay. So I actually have a simulation where I have done this 10 trials. And you can see sometimes I got lucky and only needed to open 3, and another time I had to open 9 boxes before I got all 3 different athletes. So how do I kind of summarize what I have here? Well, I think it makes sense to figure out what's my average of all of this. So I toss these numbers in, add them all together, and divide by 10, and I get 5.5 as my average. So my conclusion is, based on my simulation, I expect a customer to open an average of 5.5 boxes before getting all three athletes. And sometimes kids will say, well, you can't open 5.5 boxes. But again, this is an average, and with an average, you can have a decimal. So somebody might say, well, I would expect to open 6. Well, sure, I understand that, but this language is correct because averages are acceptable to have decimals. Here's a second example. 57 students participated in a lottery for a particularly desirable dorm room. It's a triple, meaning that has 3 bedrooms with a fireplace and a private bath in the tower. A lot of kids are going to want that room. Well, 20 of the participants were members of the same varsity team, and when all 3 winners were members of the team, the other students cried foul. So think about that. If you put in to a random lottery to get this special room, private bedroom, you get to share a bath with just 2 other kids, but the only ones who end up getting it are all members of this varsity team, you might be suspicious that something is rigged, like somebody in the background didn't truly make it random. So one of the ways you can test to see, is this rigged in a sense, is to run a simulation and see how likely is it, does it happen often, that 3 members of the team are randomly selected before you go accusing somebody of rigging the system. So we're going to describe one component first, which would be just selecting one roommate. Okay? So I have a total of 57 students, which tells me I'm going to need to use double-digit numbers, which would include 00 to 99, and that is 100 different numbers. So I also know 20 of them are part of the varsity team. So I'm going to let 1 through 20 represent a varsity team member. And then the remaining, which would be 21 through 57, be a non-varsity member. But I also have to address the remaining numbers, okay? So the other numbers from 00 to 99 need to be ignored. So I skipped 00. I didn't have to. Some kids like to do 00 to 19. That's acceptable. And then 20 through 56. But I'm going to ignore 00, and then I'll ignore 58 to 99. I'm also going to ignore repeated numbers, okay? Because if kid number 2 gets picked twice, it's not like kid number 2 gets 2 bedrooms. They're not going to do that. Ignore repeated numbers. So how am I going to combine this to simulate one trial? And that's where I'm saying I'm going to select 3 unique 2-digit numbers. So unique meaning, again, that I'm ignoring the repeated numbers. And what's my response variable? Well, I'm interested in, are all 3 members on the varsity team? So I'm just going to say my response variable will be like all varsity roommates. To be more grammatically correct, it would be whether or not all are varsity roommates. Okay, so we're told to generate 10 trials. So let's get started here on my first one using this random digit table that's going to be 49, 56, and 31 based on how I described it as one component. So that would produce, let's use a shortcut. So V for varsity, and then I'll use an N for non-varsity. So I do believe they are all non-varsity members. And my response variable, are they all members of the varsity? No. Second trial. I'm going to pick up with 28, 72. I need to ignore 14 and 6. So that produces a non-member and then varsity, varsity. Are they all members of the varsity team? No. Third would be the number 39, 31, and 4. So I believe that's a non-member, non-member, varsity. So again, nope, didn't happen. I'm going to pause this and then I'll just show you my results. Just started again to show you I'm on trial 5, and I wanted to point out that 48, I'm only ignoring 48 when it appears in one trial. Like 48 in separate trials is totally fine. Okay, so I have done this 10 times, and not once did I get a room that was filled with varsity members. I had one time where I got 2, but every other time, but it never happened. So what's my conclusion here? So for my conclusion, in my simulation of fair draws, 3 people chosen as varsity members never happened. If I saw it happen one time, I'd say it happened 10% of the time. But I'm suspicious. But honestly, I'd have to do many more trials before making an accusation of unfairness. 10 trials is not a lot. So how many trials is enough? Well, honestly, you probably want something like 1,000. If you're doing this by hand, I'm going to say that 20 trials is adequate. Okay, so we did it just 10 times in our examples. I'm going to have you be doing it 20 for homework.